Assalamualaikum and hello everyone, and welcome back to our course on Introduction to Algorithms and C Programming. Today we are moving into a very exciting topic, logic and comparison. Up until now, our programs have basically executed one line after another in a straight line. But what if we want our program to make a choice? What if we want it to do one thing if a condition is met and a completely different thing if it isn't? By the end of this session, you will learn how to give your programs a brain using logical operators so they can compare values, evaluate multiple conditions, and ultimately make decisions. So let's dive right in. To perform decisions, we use what are called relational operators. A relational operator compares two values and tells you how they relate to each other. For example, are they equal? Is one larger than the other? So these operators are used to control the flow of a program. So just think about this. How does a grading system know if you pass a class? So the answer is it uses a relational operator. For example, it might check, is the student's test grade greater than or equal to 50? If the answer is yes, the program makes the decision to print pass. If not, it will print fail. The operators we use for this are greater than, less than, greater than or equal to, less than or equal to, and these two equal signs means equal to, and an exclamation mark with equal sign, it means not equal to. Let's look at standard math versus how we type these operators in C. So most of these will look familiar to you from the algebra, but there is one major trap that catches almost every beginner. So look at the very first row here. In standard algebra, an equals sign means two things are the same. But in C programming, a single equal sign is the assignment operator. If we see in C programming language, only a single equal is used, it means it relates to the assignment operator. Just like we saw in the examples we've gone through previously, like integer a equals to 2, meaning integer a is assigned to b equal to 2. That's how it is. So it assigns a value to a variable, which we have learned in previous weeks. So if you want to compare two variables to see if they are equal, you must use two equal signs side by side like this. So x, 2 equals, which is side by side. Y, ask the question, is x equal to y? The other special one is not equal to. Okay? In C, we write this with an exclamation mark followed by an equal sign. So x exclamation equal sign y means x is not equal to y. Okay, that's how it means. So the rest, we have the greater than, less than, and their equal to variations. Okay, greater than and equal to, less than, greater to. So they look exactly like we would expect. Okay, so it gives the same meaning in C condition, where just like we expected that x is greater than y, x is less than y. So x is greater than or equal to y, x is less than or equal to. Just these two. Okay, so what we used to see in the standard algebra, in C program, you have to write it in a different condition using a different relational operator. So now we are stepping up to the complexity. What if a decision depends on more than one condition at the same time? So can anyone recall a time when you needed two things to be true before you could do something? Like, for example, I can go to the movies if I finish my homework and I have enough money. So that is exactly what logical operators do. On the screen, you see a diagram of logic gates here, which represent how computers process this combination. The true, false combination in logical operators. So logical operators let us link multiple smaller conditions together to form one big decision. Logical operators are essentially the manipulation of logic. In C, the two main logical operators we use are A and D, and which is typed with two ampersand like this, and OR, which is typed with two vertical pipes. So let's look at the first example on the slide. If midterm is greater than 60 and you put ampersand here, final exam greater than 50. And then we have print function with a string pass inside the bracket. So this reads as, if the midterm score is greater than 60 and the final exam score is greater than 50, then print pass. So both of these conditions must be true for the student to pass. Now look at the second example. We have if midterm less than 60 with the two vertical pipes here, and the final exam is less than 50. Print fail. So in this case, if either of those bad scores happen, the student fails. To visualize how the AND operator works, we use something called a truth table. So this is how the truth table looks like. So look at the columns expression 1, expression 2, and the combined result using ampersand. So with the logical AND operator, the only way the final result is true is if expression 1 is true and expression 2 is true. If expression 1 is true but expression 2 is false, the whole thing becomes false. if the first is false and the second is true, it's going to be false. And of course, if they are both false, the result is false. So think of it like a strict underground staff at a concert. So if you want to go to a concert or you want to get in, you need an ID and a ticket. So if you are missing either one, either your ID or a ticket or both, you are absolutely not getting inside. So that's how one can put as an analogy. So now let's compare that the truth table of AND, to the truth table for the OR operator. Okay, so the OR operator is much more forgiving than the AND truth table operator. So in this case, for OR operator, as long as at least one of the expression is true, the final result will also be true. So if expression 1 is true and expression 2 is true, the result is true. If expression 1 is true and expression 2 is false, the result is true. If the first is false but the second is true, it is still true. The only way an OR statement evaluates to false if both expression 1 and expression 2 are completely false. Now that we have introduced all these new relational and logical operators, we have to talk about operator precedence. Just like standard math has an order of operations, C also has a strict hierarchy for deciding which operators execute first when they are mixed together in one big line of code. So at the very top here, executed first are our unary operators. So example of these unary operators are like the logical NOT, okay, with the exclamation mark, and positive or negative signs. So next comes our multiplication, division, and modulus, which represented by asterisk for multiplication, slash forward represents the division, and percent for modulus. And then followed by next is the binary operators. We have plus and minus sign for addition and subtraction. But here is the new part. So once the math is calculated, the computer then looks at relational operators. So it evaluates less than, and equal to, and or greater than, equal to, or the greater first. After that, then it will evaluate equality, which is equal to or not equal to. So finally, right near the bottom, it evaluates our logical operators. Okay, so logical AND with the ampersand is evaluated before the logical or vertical pipe signs. And the very last thing that ever happens in the assignment operator, which is a single sign, which is storing the final answer into a variable. So the sequence, this is what we call the precedence, okay? So this is how you should follow if all these operators, let's say maybe all of them, or maybe some of them are written in a big line of code. So what you need to evaluate first by sequence is to follow this precedence. Okay, the first, second, third, fourth, fifth, sixth, seventh, and the final one. So let's put this into practice with a past year final exam question from 2016 and 2017 academic session. So question 1 asks us to write a C expression to represent this English sentence, which is x is either equal to 10 or not greater than 5. That's for question 1. For question 2, gives us complex mathematical equations and asks us to convert them into valid C expressions so the computer can process them. The first equation multiplies some fraction here, a a divided by b, and variables together, and the second involves large fractions with variables in the denominator. So from this past year question, just take a moment and think about how you would write the code for question 1. So remember, for question 1, it's about using relational and logical operators. So let's see how we should solve this. For the first question, x is either equal to 10 or not greater than 5. So the answer is, you should write it like this, using relational and logical operators. So x x, two signs are equal, okay, 10 with the logical operators of OR here, vertical pipes, okay, with the x less than 5, okay, not greater than 5. So notice we use the double equal sign for equal to. So the two pipes here for the logical OR, and since not greater than 5 mathematically means less than 5, so we write it as x with the symbol 5. Okay, that's for the first question. So for the math conversion, we have to remember our operator precedence, the sequence, okay? Which one to evaluate first? So for equation 1 here, the valid C expression is written like this here, which is the A divides with B in parentheses, and you multiply with the parentheses of C multiplies by C and multiplies by C, and then multiplies again with parentheses of 1 minus x. So because C doesn't understand algebra symbols like C to the power of 3 here, or numbers sitting next to the letters, okay, so we must explicitly write out the multiplication using the asterisk symbol and group the terms with the parentheses. That's for equation number 1. And for equation number 2, this equation will become, or can be write as like this one. So it becomes the parenthesis of 10 multiplies with the asterisk symbol with the C multiplies with C, multiplies with C, and multiplies with C, minus sign, 2 multiplies with X divides by the parentheses of 6 times A times B times C and times D. So notice how the entire denominator here is wrapped in parentheses. If we didn't do this, the computer would only divide by 6 and then incorrectly multiply with the rest. So let's look at one more past exam question. So this time from 2015 and 2016 academic session, which asks us to write an entire sequence of C statement to accomplish a specific task. So we need to first declare variables A, B, C, and Z as integers. Second, to display a message prompting the user to enter 3 integer values. 3, to read and store those input values into A, B, and C. Fourth, compute Z using the algebra equation. Z equals 2 times A squared plus 4 times B, and all divided by C. And finally, display result of Z is with this string followed by the value. So let's look at the solution on the final slide. So here is the step-by-step code solution. So for step 1, integer A, B, C, and Z. So this safely declares our integer variables. So if the question asks you to declare variable A, B, C, and Z as integers, you write like this. Okay. As you can see from here, this is the marks assigned to how the solution, or let's say this one, if you write this integer A, B, C, Z with all the commas and all the semicolon, you will get 0.5 marks for each variable. That's how the marks were assigned to this particular question and solution. Okay, so for step 2, printf, please enter 3 integer values, because the question wants you write how to display a message to prompt user to enter 3 integer values. So you use the printf function, and then you use the string please enter 3 integer values, okay, with the end line here, close with the double quotation mark and the parenthesis, and don't forget the semicolon. This will give you a full of 1 mark. Okay, so note this here, this double quotation mark is supposed to be in the opposite way around. Okay, I think this is just a error, typo error. Okay, and for step 3, scanf, we use scanf function so that this waits for the user and stores the 3 type integers into their respective memory addresses using the ampersand. Okay, the ampersand here, only a single one. Okay, so you use a scanf function. Again, correct this double quotation mark is supposed to be the other way around. Okay, and then you put %d for 3 integers A, which refers to A, B, and C. So this will give you 2 marks if you write this in full. Okay, step 4. So here comes the big calculation. We write this equation here, okay, in C programming. We write this in like this. So Z equals to parentheses of 2 multiplies with A multiplies with A plus 4 multiplies with B and slash forward, which represent division by C. So just like before, we expand the square into AA here, okay, and explicitly use asterisk for multiplication, and use parentheses to ensure the top of the fraction is added together before the division by C happens. And finally, we output the result with printf, because the question wants you to display result of z is followed by the value of variable z. So you output the result with printf function with a string. Again, change this the starting of the double quotation mark to be the other way around. If the string of result of z is %d with the variable z. Okay, this will give you the full of 1 mark. So, and that brings us to the end of today's session on logic and comparison. To summarize, today we gave your code the ability to make choices. So you learn how to use relational operators like greater than, less than, and equal to compare data. Then we level up by using logical operators and or to link multiple conditions together, allowing for complex decision-making rules. After that, we also learn how to read truth tables and review the strict order of operator precedence that the C compiler follows. And finally, we look at these actual past year exam questions to practice translating English logic and complex algebra into syntax that C language can understand. So make sure you review these truth tables and precedence rules, because in your upcoming topics with Dr. Aimi, all of you will use these exact operators to build if-else statements, which is where true programming logic begins. Thank you for your hard work today, and I'll see you in the next lecture. Assalamualaikum.